Hadoop Spark, I do it on the on-prem, right? I install on Ubuntu, right? Ubuntu and install the Hadoop Spark. And next is like I install the other tools, databases like Elasticsearch, okay, Mongo, Cassandra, right? So these are the NoSQL database. So and SQL database is MySQL, okay. And Hadoop Spark Hive I installed, and Elasticsearch, Mongo. So I have done all this integration. So we have completed all these like different integrations and the Spark ETL pipelines, right? Spark ETL pipelines, right? Ingestion of the data, analytics of the data, and loading data into target, loading into target data store. So see, for any ETL, like when we are doing ingestion or sources or target, it could be anything. So source, we can say like file system, like flat files. So flat files are CSV, JSON, XML. These are the flat files, CSV, JSON, XML. Okay. Or we can say we are reading the sometimes the different file format data, right? Parquet, ORC. Okay, so you have already known about all this. I have covered in Hive, Agro, what are these file formats. And apart from that flat file, like we have a SQL database is also the source. So SQL databases category, we have covered MySQL only, but MySQL is the same like other databases. So the SQL, all SQL is covered as a MySQL. And NoSQL databases we cover, right? Cassandra, Mongo, Elasticsearch. Okay, Elasticsearch. So we have seen this ETL pipeline by using these source and targets. Okay, and then we came to the AWS cloud. So cloud, we started the cloud services. So starting services like EC2 and S3, these are the two fundamental services. And VPC is virtual private cloud. Okay. So these are the fundamental services. But when we do AWS data engineering, right? When we talk about AWS data engineering, so we should have the knowledge in analytics services. So in the AWS, we have analytics services. Glue is there, Lambda. So Lambda, and we have EMR. Okay, so EMR we can run a Hadoop Spark job. Okay, our Hadoop Spark and Hive, everything we can scoop. These all we can run in EMR. Lambda is Python, right? It's a serverless. Okay, so Glue is also serverless. So serverless is we don't need any EC2 instance. Okay, we don't need any machine, server machine. So it's a serverless, and Lambda can be used in a different runtime environment is there. Python is there, Java is there, C# is there, but we use Python. Glue is also a serverless, so serverless ETL. So whatever, right, we are writing a ETL pipeline code here, right? We are writing here we are writing a Spark ETL. The same Spark ETL. Here also we are writing the same PySpark or Spark Scala options are there in Glue. So we can write our ETL job, the Glue ETL job, we can write a same code, but here the resources, this Glue job is taking the resources from AWS. So what type of resources? Like, okay, it is reading the file from the S3. Okay, S3 is an input file, and write output file in S3. So here is Glue will be using the resources from the S3, or it can read the data from. Another scenario is like reading data from Redshift and writing to the RDS. So there may be many combinations. So Redshift to RDS, okay, or RDS to Redshift, okay. So Glue is providing the connectors, right? So I will show in Glue, then you can understand like how Glue works, okay. And now next is this is the cloud part. So cloud is various clouds are there: AWS cloud, Azure cloud, GCP cloud. So respective services are there. Data engineering services are there in the Azure. So Azure data engineering. So this is called Azure data engineering service. So Azure data engineering services are ADF, Azure Data Factory, Azure Databricks. So Databricks is common. So Azure Databricks in AWS also for analytics we use AWS Databricks. Okay, so AWS Databricks is a integration, basically we can say, and GCP has GCP Databricks. Okay, so Databricks is common. Okay, but it is cloud specific. Databricks is there. Okay? But the actual Databricks functionality and everything is same, but only cluster setup is different way. So Azure is having a Azure installation, right? Azure configuration we do the Databricks setup. AWS having AWS, and GCP has GCP Databricks. And other than the other services are there in Azure, so many other services. Snaps is there, and Event Hub is there for streaming services. Event Hub. So Event Hub is streaming. So if we call here in AWS, Kinesis. So Kinesis is a service for streaming. So it is a streaming, right? Similar to Kafka in AWS. Again, so here is a event hub is there, and Azure function is there, like a Lambda. So you have to find which services are same, and then accordingly you can prepare the Lambda in AWS. So if you know one cloud, then you can prepare another cloud. And GCP has GCP Databricks and GCP Dataproc. So Dataproc is a Hadoop Spark cluster, same like EMR in here. So Hadoop Spark, five school, all are there, GCP. Okay, Dataproc. And there are some more services are there, PubSub is there, and BigQuery, BigTable. Okay, and GCS is Google Cloud Storage. This is storage, file system storage. Same like S3, file system storage, same as S3. So we can compare it and then we can understand. Now, next is the cloud. Like we need to know the DevOps. Okay, because DevOps is infrastructure tools. DevOps is the infrastructure tool. So it's not part of development. DevOps is operations. So infrastructure setup is done in DevOps. Okay. So nowadays, DevOps is a part of like the learning process, or we can say nowadays DevOps tools are being like anybody is expecting the knowledge of the DevOps tool. So one is a Git. So Git is very, very essential tool. Like when we are doing any code check-in, check-out, so we should know the Git command. So code, check-in, check-out, check-in, check-out, everything that we can learn through the Git. And another one is a Jenkins. So Jenkins is a CI/CD tool. So we know, right, any automation we want to do for our pipeline. Like suppose this my ETL job is Spark, and I want to trigger it as automatically, right? Whenever the code is changed, right? So I want to trigger automatically my job. So CI/CD pipeline, there are the various stages are there in the pipeline. So Jenkins is one tool, but there are many other tools also there. GitLab is there, one tool, and GitHub Action is there, another one. GitHub Action. So GitHub Action is there, and GitLab is there. So GitLab is from the GitLab. GitHub Action from the Microsoft, right? Because the GitHub is from the Microsoft. So and Jenkins is Jenkins one. So CI/CD pipeline having all are using a different way. Like GitLab and GitHub Action, they are using YML files. They are using YML file, and YML is a tree-based structure. Okay, and when we say in the Jenkins, Jenkins is having the Groovy script. The Groovy script is used to define Jenkins stages. Okay, so there are the different stages are there. We need to understand what are the different stages. Like clone is the first stage, then build, then test, deployment. These are the various stages. So we create a Groovy script, and we can schedule our CI/CD pipeline. So we can install the Jenkins in the Ubuntu, and then we can run the Jenkins CI/CD pipeline. Okay, and Git is used for the code repository tool. So it's a code repository management tool. So code repository management tool. So that is Git. Okay. any other tool is there apart from this, that is Docker. So Docker and Kubernetes, these are the two orchestration. So Docker is a container management tool, containerization tool. So container management tool. So like we have virtual machine and containers. So what is the difference between the virtual machine and container? Okay. So if I compare, container is very lightweight. Okay, containers are the lightweight, and virtual machine is the not light. Okay, because the virtual machine, like, you have dependency on your operating system. The virtual machine has dependency. Okay, like virtual box, right? It's a like a virtual machine, so has dependency on guest operating system. Okay, so guest operating system, okay, system has a dependency. Like example, virtual box, and it takes time in boot up. Okay, it takes time boot up, and it's more memory intensive. It is more memory intensive. Okay. So these are the some drawback. Okay. But still we use virtual machines. Okay. But containers is giving more flexibility. So we can create as many as number of containers, and these are the not that much of memory intensive, and it is faster to boot. It is faster to boot up. Okay. And it is a lightweight. Okay. So even if I want to install like my Ubuntu as a container, so it will be very, very lightweight. Some MBs of container, like we can download. It will not be giving you the user interface, but it will be giving you the command line interface. So we can pull image of pull Ubuntu. So any container you want to pull, right? So you have to use the pull command. So basically, containers means images. So what is the difference between image and container? Okay. So when I say image is a logical artifact, logical means when it is stored in a repository, then it is called image. Okay, repository. But when it is when image is what is container? Container is when you download image, when you pull image from the repository, pull image from repository, okay, from the repository and run the image. So when you run the image, it will become the container and it will be contained. So it's called physical copy. So physical copy is container. Okay. So we have a command Docker. Yes. The Docker PS will give, it will show all running content, all running container. If I want to see only not running, Docker PS minus A, not running content, all content. PS means A. Docker PS minus A, which is to show all container, whether it's any state. Okay. So all containers, running or not running. Even some container is the stop container. You can see. Okay. So what is Kubernetes? Like, okay, we say the Docker is already a container management tool. So what is the Kubernetes? Kubernetes is giving the orchestration, right? Like multiple containers create a cluster. Okay. So we can orchestrate, right? We can schedule, right? Scheduling things we can do in Kubernetes. Okay, scheduling on containers. Okay, so in the Kubernetes architecture, right, it is giving microservices, microservices architecture. So microservices architecture, like high availability, scalability. So those all features. Scalability. So we can have multiples uh, like a node, right, which is handling your request. So if one node is down, so another node will be providing the handling the request. Okay, but Docker also has the orchestration. There is a Docker Swarm. So Docker Swarm is giving, but it is not that much capable of as a Kubernetes. But Docker Swarm is an alternate, and Docker Compose also. So these are the utilities of Docker. Okay, this is okay. So if we come to the DevOps, right? So our learning, like it is not very deep dive. You have to go in Docker Kubernetes. Even Jenkins also, we need to understand and write a small shell script, a small script for the Groovy script. That is sufficient. But Git should be good to learn, right? Because the good Git is mainly used for code check in, check out, and is we use in like it. Okay. So if we start the Git, so these are the four tools. Okay, but mostly we concentrate on the Git and Jenkins. But Docker Kubernetes is just high level understanding of Docker CI/CD pipeline. Docker, we can even Docker Jenkins integration and Docker Kubernetes, Docker Jenkins integration also there. Like you can build your images, build your Docker images through Jenkins CI/CD. Okay. So if you are using only Docker means you are manually building and running the containers. But when you are building your containers, building your Docker image and running your Docker image and running Docker images. Okay, automation. Right? So Jenkins is automation too. And when the same thing comes to the Kubernetes, right? So I say uh, I'm using, okay, so Docker Kubernetes combination is there because Docker is a prerequisite for Kubernetes. Okay? So Docker, Kubernetes, and Jenkins pipeline. So this is another pipeline. There we are containers. Same thing. Containers will be orchestrated by Jenkins is doing all the automation things. Okay. So entire like Kubernetes setup, right? Kubernetes that is setup is run through Jenkins. Yeah. Okay. So there will be, so Jenkins has plugins basically. So Docker plugin we have to add, and Kubernetes, we have a Kubernetes plugin we have, Kubernetes plugin. Okay. And we are writing when the CI/CD, okay. We are writing a CI/CD in Jenkins. So we have to define one stage for Docker stage we can define, and one stage for Kubernetes we can define stage. So there we will be doing the deployment part. Okay. So here we will be defining the deployment. So deployment is nothing but you are deploying your application on the Kubernetes container. Okay. So this all is called, this DevOps infrastructure is called DevOps. So we call DevOps, right? So DevOps is just simple development operations. But when we come DevOps with data engineering, right? So it will become data plus operation. Data plus operation, and it is becoming DevOps. DATOPS. So in DevOps, we need to understand the infrastructure setup things. So if I'm saying like how usually do your infrastructure if you're not using the DevOps. So you are having a virtual box and you have installed in VirtualBox, you have installed Ubuntu, and then you are setting up all the manual installation. So manual installation you are doing for setting up infrastructure, setting up the infrastructure, right, for running data engineering jobs. If I say this manual installation, instead of that, you would like to do through DevOps. So if I say I want to do with the DevOps, so what I need, right? Suppose I'm saying one Spark ETL pipeline I'm going to write. I'm just saying what manual installation you are going to do. So you need a Spark ETL pipeline. You are going to schedule through Airflow pipeline and schedule through Airflow. Okay. And this ETL pipeline is using some Kafka also. Suppose he is using Kafka Spark Stream before. Okay. So if you understand here, how many tools you need, Spark you need, Airflow you need, and you need Kafka you need. Okay, and if you are reading a data from the Hadoop, so Hadoop you need. So this entire infrastructure you have to do manually. But when I do with the DevOps, right, when I'm using DevOps, so I need a containers for all these setup. So if I'm using a Docker, so Docker having a one Docker compose file. So there is a Docker having a one Docker file. The Docker file, you can write one container, only one container you can write. So better to only one Docker file can be there. But if I want these four containers, I want to do one container for Spark, one container for Airflow, one for Kafka, and one for Hadoop. So I will have one Docker Compose, and this Docker Compose file have this Spark, Airflow, Kafka, right, Hadoop, all will be defined in a one compose file, and you will run just Docker Compose up command. Okay, where is your Docker? So this file name is Docker Compose YM, Docker hyphen compose.ym. And this, wherever this file is there, just you run this command. After that, you will see Docker PS command. You will see the four containers running. So this container once running, so now next thing what you will be going to do. If you have a Spark container, so you have to run a job in a Spark container. You have to set up a Airflow, which will running your Spark job. And Kafka is basically integrated with the Spark. So Kafka, you have to create a topic. So you know, right, in which container what to do. Like suppose you have some file you have to read from the Hadoop file system. So you will write the data in Hadoop file system in Hadoop container. Kafka, you will create a topic. Airflow will be configured for running a Spark job, and Spark will be running your Spark summary. Okay. So this all containers, these all four containers, you will be configured. Okay. So this kind of pipeline. Okay, I show you some code so that this guy code. So any DevOps project we take it, right? How he has done for DevOps. So first we need to understand like how we can use the Docker, right? So all Docker compose YML file. If you see this YML file, in this YML file, all the containers are there. First, we are defining the Hadoop services, right? So Hadoop services, setting up the HDFS in YARN. So name node and volume of the name node. So what is the volume? Volume is like your host machine and you want to connect to your container, because container is a part of your host machine, but you cannot write the data directly in the container. So you have to define some volume. So volume is basically your your container location will be mapped to some your current directory. So suppose I say my current directory is where is my project, right? I'm saying some current directory. I'm just my Hadoop name node directory. I'm just mapping to the this container directory. So whatever I keep it in this name node directory, it will be copied. It will be mapped to this Hadoop name node directory, right? Container directory. So something you are copying in the your local machine in some directory, it will map to the container directory by using the volume. Okay. So first we define the name node, we define the data node, we define the resource manager. This is completely Hadoop part. Node manager, history server. So till here, it is completely Hadoop configuration. So this same configuration, you can use it because this image, is like somebody has created an image and this image will be pulled up. Right? This is a public image. So in the Docker Hub repository, this image is a public image, or some official image also you can pull up, like somebody is using the official mode. And second one is your Kafka container. So Kafka container, you are creating a Kafka container broker, right? So container name is a broker, and you are telling the which port it will be running. Some schema registry is there, right? So this is all Kafka related. Suppose you want Hive also. So Hive server, you have another container. Okay, Hive Metastore. Okay, and who you need, and suppose you want some external DB, right? Some Postgres database and Cassandra. So Cassandra is a part of your pipeline. So you say you are reading data from some streaming data you are getting, right? Some uh, log server files data, and Kafka is writing data to the like Spark is reading the data from the Kafka topic, and then Cassandra you are finally writing. So here Airflow also. So basically here this is the composed YML file. This composed YML file we have to run by using Docker compose command. And once you will run this, you will get all these, like all containers will come. So when you use like this Docker compose YML file up, and then after you can go to individual container, right? So there are some Docker commands are there. So you can use like a Docker exec command, Docker execute, right? So you can go any particular container, so Docker exec and -it interactive and container name and bin bash. So suppose I want to go Spark container. So I will give the container name of Spark, and then I will go to the inside the container. So whatever you want to do in container, right? You want to create a Kafka topic in Kafka container, Spark container, you want to run a Spark submit job. So you can define your configuration things in the respective containers. Again, so it is telling these are the HTTP URLs. Once your and here is a port forwarding is there, because how you are able to run on the local host, because your port is mapped to the local host. Okay, if you see in the containers, so you are doing the port forwarding. So one is an internal port and one is an external port. So if you are saying like my internal port, this is my container port, left side one, and right side one is an external port, that is my local host. Okay. So if I'm saying 9870, so already if you are running any, like suppose if I say Hadoop already I'm running, right, in my Ubuntu. So your conflict, it will conflict, right? Because the container port you are making it same 9870. So what you need to change, this 9870 of container port you will map to 9871 if you are already running Hadoop in your Ubuntu. So this is called port forwarding. So port forwarding means container port, like you have to forward to the external, like in your local host. But you cannot use the same 9870 for container as well as your local Ubuntu machine, right? So you have to make sure, right? You have to change your port, otherwise it will only one running at a time. Okay. So this container one is basically when you uh, stop the containers, right? You run a command docker compose down. So if you run the docker compose down, then it will stop all the content. So it will not access in localhost. Okay. So once your containers are running, then you can. I will show the one complete pipeline, right? How the pipeline with using this end-to-end pipeline where we are doing the job, right? Where we are running a Spark job and which is reading data from Kafka and writing data to the Cassandra. Okay. So so Airflow, right, is a scheduler tool, but Airflow is part of like basically your container, right? Like basically you are running this job through Jenkins, and Jenkins will be managing this entire job in this Docker, uh, here Docker compose. Okay. So first you have to make it all your containers up, and then you can trigger your job, right? Through CI/CD you can trigger, or manually Airflow can trigger. Okay. So there are the, in Airflow is basically you have operators, right? We have, so first we have to make containers ready, and once our containers are ready, right, then we can export using. So suppose this project, okay, git clone. So in this repository, so this is a Docker compose file. So Docker compose file will be, okay, so there are the two are there. So this is Slurry, and one is local. Slurry is for distributed environment. So you have different containers, right? Redis is a one. So services will come. So services Redis is there. So some Airflow related, this is the Airflow, okay. And Airflow and this is a scheduler, and okay, this is for Airflow scheduler. This is for Airflow worker. Okay, here is the Kafka. So this is not a Spark one. That is the reason here Kafka, Airflow, all those are not there. This example. This is just only Kafka is there. This is the different one. So this is a Docker Compose YML. This YML file is the program for the end-to-end setup, right? So this one has Kafka zookeeper, and Kafka is also multi-node cluster. Okay, Spark is there. This is a Spark, and so Kafka and Spark is here. So this is the example code. So we have to git clone this one, and we can run the Docker Compose file, and then we can Yeah, this is the Kafka UI, right? Kafka UI will come on this port 888, right? Okay. So, and Cassandra, we can go to the Cassandra cluster and then we can CQLSS command. We can create a table. So these all things we learn in the Cassandra. And then we run a DAG. Okay. So we can run the DAG of Python and then Spark. So if I want to go to any container, so I have to use Docker exec command and I'm going to the master, Spark master. And there I'm doing a Spark submit. This Spark submit, I'm running the job. Okay. So this is through Docker. Same thing if we go for Kubernetes. So we have to use Kubernetes architecture. There we have to install pod, replica set, containers. So container is a basic part, right? That is using the Docker, but Kubernetes is giving more high availability and scalability things giving by using the pod. Okay. So pod is called the application, right? Running in the container. Okay. Okay, let's see first this example to run, write some examples so you will come into. Let me give this link, you can go through this pipeline. So here you can explain, this is a Hadoop infrastructure pipeline, but you are using Docker. Here the Docker is the container tool. Okay, I will show tomorrow this DevOps related this Docker pipeline. And there is one.
Yeah, Arvind. Yeah, can you share that? What, not this one.
Okay, okay,
Uh,
one. If you want to
notepad.
see one video,
Notepad. Notepad.
on that I will share that I will add in the classroom. Yeah.
Yeah.
So if you see in my channel now, so there are the
Okay.
this is NiFi Kafka Spark Docker. So this project code I will give you. Okay, this is the this pipeline. This pipeline is I have explained that so, so this is the all the steps are there, right? This is a NiFi pipeline, how to read data from NiFi. So all these containers are running. If you see here, so this is a YM. This is the composed YM. Okay. So so in this example, you can see how an airflow also there. So this is okay. Let me the notes I will share. Notepad.
Yeah.
Okay, this video.
Yeah. Definitions, everything.
Okay. Okay. Thank you.
Okay.